This is the 13th video presentation for the CASE Ag Power and Technology course. As you view this video, be sure to make notes of important information. Feel free to pause, repeat, and resume the video whenever necessary. Ohm's Law, Lesson 5.2, Electrical Energy. You have learned the difference between an open and closed circuit while completing Activity 5.2.1, the complete circuit. This presentation provides information about measuring electricity in a closed circuit. Even though you cannot visibly see electricity, it can be measured. Amperage, voltage, and resistance are units of measurement used to calculate electrical power. Amperage is the unit of electrical current. Voltage is the unit of electrical pressure. Ohms is the unit of electrical resistance. Amperage is the flow of electrons through the circuit. The greater number of electrons through the circuit, the greater the amperage. A fire hose has a much larger volume of water because of the size of the hose. Therefore, it has a greater amperage. Resistance slows the flow of electricity. Smaller the material electrons are flowing through, the greater the resistance. The sprinkler resists the flow of water and therefore has a greater resistance. Measure resistance in ohms. Voltage is the measurement of electrical pressure. Electrical pressure is how forceful electricity is as it flows through the circuit. The sprinkler increases the resistance, which increases the pressure of the water. There is a direct relationship between electrical pressure and resistance. As resistance in a circuit increases, the electrical pressure increases. Find electrical resistance, or ohms, in a circuit by dividing the number of volts by the number of amps in a circuit. You can use Ohm's law to solve for voltage or amperage in a circuit as well. Voltage is equal to amperage times ohms. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. During Activity 5.2.2, Amped Up, you will calculate amps, volts, and ohms in a circuit using Ohm's law in order to understand the relationship between amps, volts, and ohms. Your teacher will provide more information for the activity. During the activity, you'll use the vernier energy sensor. The following clip provides an overview for use of this sensor.
Hi, I'm Fran Poudry with Vernier, and I have our energy sensor to demonstrate. The energy sensor measures both voltage and current when connected to a source of electrical energy and a load. For my source of electrical energy today, I'm going to use our Kidwind Advanced Experiment Kit. So I'm going to connect that over on the source side. For my load, I'm going to use the Vernier variable load. When you hook the energy sensor up to an interface or a computer running our latest software, then it will automatically pull up a set of meters to show voltage or potential, current, power, and resistance. It will also show energy on a computer, but this screen is too small. So first thing you want to do before taking any data is zero the sensors. And that brings everything to 0. And I do that with current as well. I am going to turn on my off-screen fan to power this. And as you can see, the meters read potential, current, increasing power, and it calculates the resistance as well. I also want to collect some data. I'm going to do that for about 30 seconds. All right, now that I've collected data, I can turn off my fan. And what I'd really like to do here is see the total energy. So I'm going to show one graph and change this from potential versus time to power versus time. Then, in order to figure out the energy, I'm going to take the integral of the power versus time. And I find that during those 30 seconds, I generated 808.5 milliwatt seconds of energy. For more information on our sensors, such as the energy sensor, please visit our website.